Hello everyone, welcome back to the channel. Today we are going to break down one of the most important topics in structural engineering, that is the steel structure design process. If you have ever wondered how engineers go from a simple idea to a massive steel building or a bridge, this video will give you a complete step-by-step understanding. So let's recall. Before jumping into the process, let's quickly recall what steel structure is. We have already seen that steel is strong, ductile and reliable. But just having a strong material is not enough. The real challenge is how to design it properly so it performs safely in real life conditions. Think about this. Would you trust a building designed without calculations? Definitely not. In this video, we will cover three major things. First thing is why and what is a steel structure and how it is used, why the design process is more important than the material characteristics, and most importantly, the step-by-step steel design process. By the end of this lecture, you will have a complete roadmap of how engineers design the steel structures. The topics for discussion are importance of steel, the process of steel design, and the types of steel structure. A steel structure is a system where the primary load carrying members like beams, columns, and trusses are made of steel. These members are connected using bolts or welding to safely transfer the loads. In simple words, steel structures act like a skeleton that carries all the loads of the building or a bridge. A real life example, next time you see a flyover or industrial shed, remember this, you are looking at a carefully designed steel structure. Now let's understand why the design process is so important. The first thing is safety and reliability. A poorly designed structure can fail. Second is economy. We don't want to use excess material unnecessarily. Third is speed and adaptability. Good design helps in faster construction. And finally, future adaptability. Structures should allow modifications later. So basically, good design is the difference between a safe, cost-effective building and a disaster. So designing a steel structure is like balancing strength and efficiency. If you over-design, it becomes expensive. If you under-design, it becomes unsafe. So the goal is to find the perfect balance between safety and economy. The first step is structural planning. Here engineers decide the layout, where columns go, how beams are arranged, and what type of structure is suitable. This step is like creating a blueprint of the entire system. Next comes load calculation. We consider different types of loads such as dead load, that is self-weight of the structure, live load, the people, furniture and other moving parts, wind load and earthquake load. This step is critical because a wrong load estimation leads to wrong design. So once the loads are known, we analyze the structure. We calculate internal forces like bending moment, shear force and axial force. Today softwares like STAAD or ETABS is commonly used for this. Now we choose the design method like working stress method or limit state method. In modern practice, limit state method is widely used because it gives better safety and economy. So next step is design of structural steel members. In this step, we design individual members like beams, columns, and trusses. We ensure each member can be safely carrying the loads without causing any failure. Next step is design of connections. Connections are equally important. Even if members are strong, weak connections can lead to failure. So we design bolts and wells carefully. Next step is serviceability checks. Here we check for deflection, vibration, and usability. Even if a structure is safe, excessive deflection can make it uncomfortable or unstable. Next process is detailing. Detailing means preparing drawings with exact dimensions and specification. This is what contractors use during construction. Next step is safety and economy. We ensure the design is safe but also cost effective. This is where optimization plays a key role. Next, the codal provisions used are: we follow design codes like IS codes such as IS 800 2007, IS 875 Part 1 to 5 for load calculation, and IS 1893 for earthquake load calculation, and SP6 for selection of steel sections. To summarize, steel design is a step-by-step process starting from planning to final detailing. Each step is interconnected, and skipping any step can lead to serious issues. So, try to answer these questions by yourself. What are all the steps in steel design? Why load calculation is very important? And the following references are based on standard steel structural design resources and engineering practices. So if you found this video helpful, don't forget to like, share and subscribe. Also comment below what topic should I cover in the next coming videos. See you in the next lecture. Have a good day.